Hey, happy Friday, everyone. How you doing? This is TGA number 48, and I am Duffie Cooley, your host for TGA. Very good to meet you all. I can see we've got quite a few people already logged in, throwing comments from all over the place. So hello to everyone. We've got, let's see here, we've got Maddie. Hello, Maddie. Good to meet you. Good to interact with you on Twitter, and thank you very much for the warm welcome. Kalicia will be our moderator today, so any questions and anything, just throw them in the comments and she'll make sure I see them if I don't see them. So please feel free to ask questions as we go along. I'm also welcoming Giorgio139. Welcome to the show, Suresh Vishnoi, visiting from Hamburg. We have some folks from Phoenix, Arizona. We have John. We got Roy from Toronto. We got Leonardo from Brazil. We got some people from Bristol. I'm presuming that might be England, but I'm not totally sure. Welcome to San Diego to Peter Benjamin and Lalam from Boston. And Dimitri from Serbia. Eddie Hernandez from Guatemala. Antoine G from Paris. Antoine, it's good to see you. Nadir Jiwa from London. James Weber, one of my co-workers, good guy. Rory McCune, good friend who's also really interested in some of the security stuff. Joe Searcy, one of the people I work with pretty frequently, and some other good friends. It's so good to have such a warm welcome. Thank you all for logging in. I really do appreciate it. So, welcome to TGI K8 number 48. So, now let's get underway here and talk about our plan. So I wanted to I have the HackMD thing set up just like we did last week. So this is kind of where we're going to be keeping the notes for this particular episode. And this is what we're going to cover and like all that good stuff. We're going to start with the welcome, which we've already done, which is awesome. Again, welcome to everyone. The next thing is, who the heck am I, right? I'm Duffie Cooley. I'm a field engineer for Heptio. And prior to coming to Heptio, I was at CoreOS for about a year, helping build and support like the Tectonic product and really kind of focus on Kubernetes in general. I spent quite a lot of time with distributed systems over the years, whether those systems are networks or I see we're getting some buffering, it looks like. Let me see if I can do something about the buffering. How you doing? This is TGA number 48. See if I can do something about the buffering. All right, is that any better, folks? I was able to stop and restart my stream. Hopefully that's a little better. Okay. Moving on. All right, so I am Duffie Cooley. I'm a field engineer for Heptio. I did this at CoreOS. Been working on Kubernetes since about 1.5, 1.6. Before that, I worked on Mesos, a large company in the South Bay, and spent quite a lot of time working with distributed systems in general. Anything from working with networks at Juniper Networks, or working with distributed systems in general. So, fun stuff. So that's kind of what I bring to the table. I've been playing with everything for far too long, and I have a lot of experience across a wide variety of things. So that seems fun. Thank you for the feedback. Looks like it's going a little better. I'm using Linux for this rather than a Mac. That's probably my problem. I probably got to get a beefier machine for this sort of streaming, which I'll take into account for next time for sure. So I wanted to kind of talk some of the show notes I have here. Anybody who wants to give put notes up, they can put these things up right in this link right here, which is v.ht.tjik48. That's the link to the HackMD document. Carlicia will be managing that, and that's awesome. Hope I'm not slaughtering your name. Moving on down the list. So today what I'm going to be doing in my demo is I'm going to be exploring Harbour, which is a container registry that is that is actually going to be, that has a couple of really interesting features about it. Like it has the ability to be hosted on Kubernetes, for example. You can also, it comes with a Notary implementation and also a charts repo implementation, so you can actually use it effectively as like a local container registry within your own environment. And there's some real value to doing that. Like as we think about the way that Kubernetes actually accesses all of those resources that might be held in an image registry, it becomes pretty clear to us that we would want to make sure that when we're downloading those 200, 300 gig, or sorry, 200, 300 meg images down from our container registry, that we don't want the nodes to have to go too far to go get that data, right? We want that to be locally relevant. Say we have a Kubernetes cluster in California and one in Texas, or one on the East Coast, one on the West Coast. We want to be able to make sure that our container registries that both of those two clusters are pointing at actually have that local big data, because we don't want to have to chase that around, you know. Yeah, it's i3. You caught me. It's coming to Heptio. I was actually really glad, because like I worked at Apple for a little while, and when I went to Apple, I broke my streak of running Linux on the desktop. I had been running Linux on the desktop since about '92. Prior to that, but when I joined Apple, so much of their stuff was ingrained with the OS stuff that I really went to a Mac. And so once I left Apple, I was still on the Mac for like another year when I was at CoreOS, and when I joined Heptio, I moved back to the Lenovo, and I'm super glad to be back on Linux. I didn't realize how much I missed it until I started playing with it again. Is it bad again? No, I wish it used torrents. I think it's actually just copying the object around, but we'll play with it a little bit and see if we get to that part. Yeah, Moody, I'm not sure. I know that Quay does use torrents for moving objects, for images around, but I'm not totally sure about that for the Harbour piece. I haven't looked into that yet. But if we get to the point where we stand up two clusters and play with that, maybe we'll get into that and find out. So in my environment, I'm going to set up a local kubeadm DND thing, and that's why I have these reference links down below. So for my test environment today, I'm going to use DND to stand up a Kubernetes cluster, and then we're going to deploy some stuff onto that Kubernetes cluster. We're going to deploy Ingress with a cert from Let's Encrypt. We're going to deploy Go Harbour on top of that, make sure it all works, and then we'll start pushing images around, kind of playing with that sort of stuff. It should be pretty fun. That's my overall plan. Before we get into that, though, let's do kind of what happened this week. So, community meeting summary. So, I don't know if you guys follow this, but there's a lwkd.info page. Definitely recommend just kind of reading through that once a week, understanding what's happening inside the community. There's a lot of really good stuff around what's actually happened around the within the community itself, and also kind of talks about some things that are good to be aware of. Like, for example, next week is Code Slush for 1.12. The KEP of the week was this Kubernetes extension proposal or enhancement proposal. This is talking about moving some of the cloud providers out of the main repo. We have a new design for kubectl plugins, which I think will actually be really interesting, because then the idea is that you could actually have a kubectl plugin just describe the binary as kubectl dash, and then whatever the name of your plugin is, and the kubectl will be able to discover it using that path, rather than having to define that plugin using like metadata within your .kube directory, which is how it works today. kubectl will just be able to find it. And if you think about it, that's actually kind of how Git works, which is interesting. Like if you actually look for all the binaries that are related to Git on on your file system, you'll find that like, Git, Git pull, Git push, all of those things are actually individual file binaries, and Git is a model to kind of discover all of those things. Kind of neat stuff. Some of the other stuff that has happened, some of the other merges, we have a couple of kind of important fixes. DNS loop detect in kubedns, which will be good. Fix buffering performance, near and dear to my own heart in this particular case, as you can probably imagine. We're reducing the work that anti-affinity checks do, because probably it just takes a little too long to get that done. That work would be in the scheduler, but interesting stuff. Some of the other stuff that's happening this week that I wanted to call out is this stuff. It's time once again, whoops, that was the wrong link. It's time once again for the voting. Maybe I messed up a link here. Let's see. Time once again for voting for the steering election committee. And it's an important time. Like with anything, you got to vote. Got to go out and vote, whether it's for, government stuff or whether it's for things that you care about, like Kubernetes. Make sure you bring that stuff up. I didn't know it was run by Josh Kirkus. Good go, Josh. That's awesome. I really like that that actually exists. So thank you, Josh. Shout out to Stephen for pointing that out. I really appreciate that. So eligibility for voting. Now we know that this is a somewhat limited view in how you could be determined eligible for voting, but we have to start somewhere, and this is how it's done. If you have 50 contributions, and that doesn't mean that you've actually committed 50 lines of code. That means that you actually comment on things that are happening within the Kubernetes GitHub repository, or you open issues, or you do contribute code, or you do stuff like that. We're using DevStats to kind of determine who has touched 50 things this year, whether that's opening or closing issues or what have you, just to try and kind of like determine a watermark for how to establish voting records. There is also a link here, because this is going to miss people. We know that. For example, I'm a field engineer. I spend a lot of my time teaching people about Kubernetes and helping them resolve a bunch of different stuff, but I don't really spend a lot of my time on the Kubernetes repository, but I do think that I should get to vote. So I voted. I went ahead and filled out a voting exception form, and we'll see what happens. I did this last year also when I was at CoreOS, and it worked out great. I was able to vote in the initial steering committee. That was great. Eligibility for candidacy. If you want to go next level, you can actually put your hat in the ring, and then I guess it's 3 people from 3 different companies can +1 you, and then you're in the running, that sort of stuff. And there's usually multiple seats, but Kubernetes, as you already are well aware, it's really all about maximum representation. We want to be super inclusive across all the things, so we really want to make sure that we get like everybody's opinion about, everybody's opinion, that everybody feels included in what is happening within the community, with regard to its governance, with regard to whether you feel comfortable contributing to Kubernetes, with regard to all of that. So help us be the change we want to see in the world. Help us be inclusive here. Terms and elections, titles, all of this stuff is actually in this doc. It's definitely worth a read. And yeah, like if you're not in the list for if you're not already identified in the list for being able to have a vote, then file that exception and get your ability to vote. Go do that. What else did we want to cover here? Another shout out to Jorge, or George, who is not here this week because he's having internet problems of his own.
Hello, my name is George Castro.
So, George has actually put up a really good video here talking about discuss.kh.io. And discuss.kh.io is kind of like a newer idea on the whole mailing list approach, right? So it's not quite as challenging as like Google Groups it has been in the past for dealing with things. But go check out this video. George describes it way better than I ever will, and you should really just go take a look at it. And you should also go check out discuss.kh.io. Which is an awesome site where we can actually like start opening conversations around things and really kind of like interact with each other on in this model, as well as at Slack. I mean, Slack, a lot of people consider Slack to be kind of like the abyss that we all stare into for a period of time. I don't personally feel that way, but there's a lot of people who are just like, there's far too much going on in Slack for me to really follow. I need a better threading model. This tries to approximate that for some people. So give it a try, see what you think. One of the things that's happening on discuss.kh.io, which I think is really interesting, is this board, which is the contributor role board. And the goal here is to actually put up requests, help connect people who are operating particular projects or some projects within Kubernetes with people who want to help, right? You can see that on this list, there are people who are asking for people to come step forward and help out with projects. And there's also people who are saying, I'm interested in helping, but I don't know what to do. So feel free to like kind of interact with that here as well. I think it's a great opportunity to kind of get involved. All right, so that was the beginning, the what happened this week and what's going on. Your big takeaway from what happened this week: get ready to vote for steering committee, and go do it. It'll be really awesome. All right, so let's start playing with Kubernetes. That's what we're all here to do. That's what I like to do. So my background is actually kind of neat. Let's just talk about that real quick. So this background is actually live updated, and it will update every hour. I started using this as a background when I was in Texas and hurricanes were a thing. I'm in California now, not so bad, but like it's kind of interesting if you live in Texas and you kind of watch that hurricane move across the bay. In fact, there's one right now headed for Hawaii, interestingly enough. So neat background stuff. I'm going to bump up my resolution here. Hopefully that looks okay. So, like I said, I'm using D&D to kind of set this up. There's some interesting stuff also that I'm using that I'll talk through here. One of the first ones I want to talk about is an incredible project called DearEnv. If you haven't heard of DearEnv, you should go look it up. It's really awesome. DearEnv is dearenv.net. I'll put a link up here. The way DearEnv works is if you're working with things that use environment variables, you can actually set those environment variables and have them referenced when you move into a directory and dereferenced when you move out of it. It's really pretty cool. So let me show you how that works now. If I look at my .mvrc here, I'm actually setting some of the environment variables that D&D uses to start up core DNS, to pick my CNI, to pick my DNS service, and to skip my snapshot piece. Yeah, that hurricane looks pretty darn intense. I'm really hoping that Pele will scare it away. Pele is the goddess of fire and volcanoes and stuff. I grew up in Hawaii. I still have some family over there, so I'm like, maybe just veer off. Don't hit Hawaii so much. But we'll see how it goes. Hopefully it'll work out. So DearEnv, here we go. So I've defined a local .mvrc in which I've exploded some variables. If I were to edit that and make up a new one, export foo equals baz. Then you hit that really cool security feature of DearEnv in which it will not actually allow the change, you have to allow it explicitly. And this makes it safe to check nvarcs and stuff like that into Git, because your local machine, unless you actually have a local allow, won't actually allow it. So if I do DearEnv allow, then those environments work, and I can echo foo and get baz, and that's really awesome. So this is really great for things like messing with Terraform, messing with Vagrant, messing with pretty much anything that uses environment variables, including kube configs, right? There's just a ton of really great features here. So let's start up our cluster. I'm going to use the fixed stuff. I'm going to do a D&D v1.11 cluster. Now the thing I like about, there's some interesting stuff about D&D, and there's also some kind of shady stuff about D&D, but I mean, you really got to start somewhere, and I think that these guys have done an amazing job of doing exactly that. Like, I didn't have to wait for very long to see a 1.11 D&D, and that's actually a pretty significant change from 110 to 111. So it was really impressive to see that happening. But some of the stuff I like about it, it actually does use kubeadm. So if you're working on kubeadm, I spend a bit of my time on kubeadm. You can actually use this this cluster as a way to kind of play with the different values or play with feature flags and do all of that stuff. That's really pretty neat, I think. You can spin up a number of workers. As far as I know right now, D&D doesn't support multi-master. It's just a single master and multiple workers. But the neat thing about that is that, like, you know, leveraging Calico and such, you can actually get a multi-node cluster running in Docker containers on your laptop. So if what you're trying to prove, what you want to exercise is anti-affinity or something that would require more than one node to play with, stuff that's like maybe a level higher than what you would normally work with Minikube, this is a great solution to kind of play with that stuff. So pretty neat stuff. You can see right now, this is some of the normal output from kubeadm. What it's doing right now is kind of generating all of the certs, creating the static pod manifests, throwing them into Etsy Kubernetes manifests where they are created, and now it's pulling down those control plane images, and then it will start up my master, and then it'll create the nodes, and then we get to play with, like, you know, like what that actually looks like on the system, because these are not VMs, these are containers. So somebody basically hijacked system in a useful way and like run it as a container, which is kind of hard to do. It runs everything inside Docker containers, yeah. And so, which is a neat feat, because effectively it's running its own little hijacked copy of systemd in each container, and that's how that's being achieved. Lamati asks, does it run everything inside Docker containers? Yes, it does. Or does it use something else like Vagrant? It doesn't use Vagrant. I've got a few environments that I use Vagrant for, but in this case, it's actually running. It's running inside of Docker containers, and it's not running Minikube actually. This is a, and in my opinion, it's kind of a better model than Minikube in a lot of ways, because you can actually have a multi-node cluster that you're playing with rather than a single node cluster. So, interesting stuff. Waiting for things to start up here. So we can see we got our masters up. So now we're just waiting for our workers to start up. Oh, yeah, there we go. So now it's deployed the Kubernetes dashboard. We can see that it's deployed our CNI, which is pretty neat. So that's all been done. We're bringing up the Kubernetes dashboard. I'm going to get into like exactly what's happening here, which is pretty neat. It's not using nspawn. It's using Docker. There is another one. There's another project that's actually using nspawn, which is, I can't remember the name of it right now, but I think it's basically Kinvolk's test harness. Can't think of it right off, but there is another one that is actually using systemd nspawn. Pretty neat. for the nodes to start up here, and very exciting stuff. Yeah, a bit more like LXC. Basically a different way of thinking of the problem. It is pretty neat though. Okay, so let's take a look at our cluster. This is the kind of the fun part. If I do Docker PS, hey look, there's my cluster. I can see that I have a master and 2 nodes running as Docker containers. I can do Docker network ls, and I have a D&D net that is connected to my local bridge. If I do Docker, if I do kubectl, get nodes -o wide, I can see these IP addresses. And these IP addresses are associated with this kubeadm D&D network, right? So when it basically leverages the Docker network mechanism to create a new network and associate those containers with it. And that means that all of these nodes are reachable via IP. So I can ping 172.18.02. I can ping 118.03. I mean, all of these IP addresses are adjacent to me. And that enables me to do interesting things like deploy an Ingress controller on top of it, or actually interact with it like a regular Kubernetes cluster. Pretty neat stuff. So let's go ahead and get moving on the Harbour stuff. So I'm going to go ahead and deploy an Ingress controller into the cluster. And before I do that, I'm going to actually create a secret within the cluster that I'm going to use to manage the kind of fall through or default certificate. And we'll talk about this pattern here in just a minute. But basically, what I've done is I've used Let's Encrypt, who is going through a round of raising money right now. Take a moment. If you have a buck or two and you've actually gotten free certificates from Let's Encrypt, totally worth supporting them. If you're really feeling generous, you can get one of those beautiful pomegranate sweaters that says Let's Encrypt up on the top. Shout out to my friend Janessa, who works there now. It's just an incredible company doing incredible work. Encrypt all the things. It's awesome. So I just generated a couple of certs. One of them is c1.k. It's a wildcard cert for C1, short for cluster1.kh.work. And I've created another one for c2.kh.work. Not sure we're going to get to the second cluster, but the first cluster we're going to stand up right now. So if I move into my certs directory, I have those 2 Let's Encrypt certs there. I'm going to look at my notes here, which is basically my Helm command to stand up my Ingress controller. And you can see that I've named the certificate Ingress default SSL. And you can also see that I'm basically passing as a Helm setting this argument as an extra arg to the controller, and the extra arg is default SSL certificate. We're going to talk about why that's cool here in a minute, but basically what that allows me to do is describe how there can be a default certificate that things can fall through to, and we'll talk about how that works here as we move through here. So first, let's create our secret. Grit TLS. Oh. Okay, so what I've done here is I've created a new namespace called Ingress, and I've gone ahead and created my secret there. And so now I'm going to actually deploy my Ingress controller into the cluster. If I pop over here, and I try and curl, blah.c1.kh.work, I can see that it's not connecting to me right now. There's no Ingress controller there at the moment, so it's not going to work for me at all. I can do that with HTTP or HTTPS. We'll talk about why blah works here in a second, but first let's, I guess we could do that real quick right now. So if I do a dig for blah.kh.work or c1.kh.work, you can see that it's resolving in a round robin fashion, sort of, to 172.18.04 and 172.18.03. Now you'll remember from before when I did kubectl get node-o wide, that those are the IP addresses of my workers. Cube node 1 and cube node 2 are 172.18.03 and 04. So I just created a public DNS record that will route a wildcard to those two endpoints. And this way, I can actually attract any host name to those two IP addresses. Right? And what that means is that anything .c1.kh.work will be attracted to these two IP addresses. Now this will only work for me because I'm the only one with access to those two IP addresses. But it actually, it makes it a little easier to kind of reason about how to attract traffic to your Ingress controllers. Now, I've also made sure that the certificate that I generated is a wildcard cert. So if I cat c1.kh.work, the cert.pem, and I pipe it on over to OpenSSL x509 text. The SAN for this, subject alternate name, you know what, that is really hard to read. There we go. The subject alternate name for this certificate is, or the, I guess the CN is star.c1.kh.work. There should also be a SAN. There it is, right there. Okay, pop quiz. Is it required to have a subject alternate name on certificates that you're going to be using to extend trust to browsers? Or can I just put in the subject name, right? Up here, is this enough or do I need both? That and the SAN. And the answer is, anybody know? The answer is, you need both. As of about, I think it was 2016, or maybe it was 2017, a lot of the browsers out there, if you don't have a subject alternate name that matches the target name, it won't, even though your subject might be totally accurate and correct, it will not actually it will not honor that certificate. You need to have the SAN as well. This is part of an RFC. I'm not going to go find it, but interesting stuff. You do need both, yes. CN is not supported by all CAs. It's also not supported by all browsers, interestingly enough. Exactly. All right, so we got that part. Now, what kind of hijinks is Duffie up to when he deploys an Ingress controller onto his cluster? Now, I'm actually going to use Helm in two different ways in this experience. The first one I'm going to use is a thing called Helm Template, which might be the most secure way to use Helm because of Tiller, but let's talk about it a little bit more. So what I'm doing here is I'm using Helm Template to generate a set of manifests that are going to deploy my Ingress controller. If I look at, this is just leveraging the standard Helm stuff, so I have a values.yaml here. This is all the settings that that are well defined within the Helm chart that I can apply changes to. I have all of the rest of my chart here, my chart.yaml. Inside of my templates, I have the template stuff. This is basically just a stable Nginx Ingress controller chart. But the way I'm going to deploy it, instead of doing tiller init, Helm init. So right now, if I do, for example, kubectl get pods all namespaces, you can see that there is no tiller running, right? No tiller running in the cluster. But if I do this Helm template command, and I pipe it to kubectl apply-f namespace ingress. Well, before I pipe it out, let's just take a look at it. So what this does, what Helm Template does, it does the templating bit for you, which is normally done client side. And here it is, right? So this is basically the set of manifests that are generated from the Helm Template and what they look like inside of there. Now, you can see already one of the caveats. If you're going to use Helm Template, you got to figure out how to get that namespace in there, because Helm is not going to do that for you, right? You can tell from the metadata associated with this config map that there is no namespace line here. We'll talk about what to do there. But all of the rest of the stuff that is necessary is all defined within this set of manifests. They haven't been applied yet, they're just templated, and it's just standard out, so what am I going to do with it? Let's go ahead and apply it. I'm going to throw this into my Ingress namespace that we created, and I need to do that because that's where I put the secret. If I don't deploy into the same namespace where the secret is, then it's probably not going to work terribly well. Although it does reference namespace and secret, so I guess technically you could have the default certificate in another namespace as long as the Ingress controller had the right permissions to go and fetch that secret. And boom, it creates all the things. I broke this intentionally because I don't want a service associated with my standard Ingress controller. I'm exposing it as a daemon set so that it will actually listen on the specific nodes host network, port 80 and port 443. And that's because I don't have a load balancer, and I don't want one. It's a local environment. So if I do kubectl get pods -n ingress -o wide, we can see, for example, that the Ingress controllers were deployed across my worker nodes, and that they've co-opted the host IP address, 172.18.03 and 172.18.04. So now it all ties together, right? So the DNS setting for star.c1.kh.work is sending traffic to 172.18.03 and 04. I have an Ingress controller that is bound to the host IP and is actually listening on the host IP at ports 80 and port 443. From within my machine, I can actually curl that stuff. So I can do curl http blah.c1.kh.work, and I can see the default backend page. Even neater, I can do HTTPS, and it's trusted. But why? So here is our wildcard cert that I put up as part of a secret. So we can see that blah.c1.kh.work matches my wildcard cert. And I can also see, because of the DNS side of things, that it is matching the DNS side of things. So it all ties together. Pretty neat stuff. I think, for my part, I think that I was avoiding Tiller because I'm going to be using Tiller here in a second. But I wanted to show both of the different methods. Like, you can actually use Helm without Tiller in some cases if security is your thing. There's also some really interesting experiences or experiments around leveraging an external tiller rather than deploying that tiller within the cluster. Maintain control of that tiller external to the cluster, like maybe in your continuous deployment process. Manage that state there rather than having that state managed inside of the Kubernetes cluster. I'm not going to get into why I think Tiller is a security problem. If you're interested in it, look into it on the internet. There's a ton of really great information around like why the Tiller model in 3.0 or in Helm 3 is changing, and all of it is really good stuff. I mean, you should just go research that. It's a great rabbit hole. I really liked it. You might enjoy it too. Moving on here. So we got our Ingress controller deployed. I wanted to go ahead and take a look at echo Ingress here. I'm going to do a kubectl create run image nginx replicas 3. Give it a name here. The kubectl run command, by the way, pretty awesome. Echo port 80 expose. Now what this is going to do is it's going to create a deployment with 3 replicas of the with the image, the Nginx image. It's going to define within the spec port 80, and then because of the -- expose, it's also going to create a service. So if I hit enter there, it's going to put all of this in the default namespace because I didn't specify. So now if I do kubectl get pods, we can see those being created. We also see some weird artifact of the way that D&D is standing up a v111 cluster. Those probably don't belong in the default namespace, but we'll leave that as an exercise for another time. So now we have our echo service. We can see that we're creating an ingress here that matches echo.c1.kh.work, both in the host path and also in the TLS spec. I'm going to send that. Oop, I've got to edit that part. Echo ingress. I want to make sure I send it to the actual service port, not this 8080 stuff. Now if I do kubectl apply-f echo ingress, kubectl describe ingress echo, you can see that my ingress controller saw the ingress get registered in my default namespace, and it created it. So let's go take a look at that guy. echo.c1.kh.work. Welcome to Nginx. It works. And we can see that we're secure and that this is our certificate from Let's Encrypt. That's all working perfectly. All right. Now the neat thing about this, again, is because we're using D&D and because D&D is using a Docker network, the IP addresses of these nodes are totally exposed. So I can hit any port on any node directly from my own little work environment, which really helps me like debug what it might look like in a production scenario. It really is, I think, if you start getting into the real detail, it's a bit more useful than Minikube in some ways. All right. So let's move on here. Let's deploy Harbour. So excited. And then we can start playing with like even the more fun stuff. So this is the Harbour chart, and it's located, let me just show you where it's located, because I shouldn't have to tell you. Let's deploy Harbour. This is Harbour's website, goharbour.io. It was recently contributed to the CNCF. It was started by VMware, or some folks at VMware. And it's a great project. I think it really kind of helps solve some of the problems that people run into when thinking about local registries. And there are some pieces of this that I'm actually pretty excited about, that they actually do have an integration with Notary and that it works. And I can show you how it's all wired up here in just a little bit. But it's like off to a pretty good running start. It does support container syncing between registries. I haven't dug into the code to see how it goes about that. I don't think it's BitTorrent, but I guess technically it could be. I'm not sure. But you should definitely go check out Harbour. For a while, they had a demo up on the. They had a demo that you could actually integrate with, but I'm not sure if that's here in the doc still or not. But definitely go check it out. Really, really cool. If you go to the, it's going to take me to the GitHub page. Where's my GitHub page? GitHub. There we go. If you go to the GitHub page, this is not what I want to do. GitHub.com, VMware, Harbour. That's better. Okay. If you go to the Harbour page, inside of contrib, inside of, docs, no, can't remember where I actually found the manifest for the Helm chart here. No, I thought it was in contrib. Darn. Well, there is a chart for it. Let's see. Helm, Harbour, chart. It was there. Oh, it's not in master anymore. Maybe it's because it got upstreamed or something. But that's where it was. I'm not crazy. Okay. I'm not sure where they moved it to or why it got moved. Maybe they upstreamed it. Nonetheless, it is there. maybe make Kubernetes. That could be it. Let's try that. Make. Yeah, I think that might be how they create the images, but I'm not going to dig into it too far. Maybe they got it upstreamed. I'm not sure, but there is a Helm chart, or there was a Helm chart in a previous branch. If I go to tags for an earlier version, I'll probably find it there. So they snuck it out when I wasn't looking. Helm Harbour. There we go. So that's the chart that I'm using. They probably maybe got it upstreamed and decided not to carry it on inside of the repository somehow. I'm not gonna try and figure that out. That's the chart I'm using. And then what I'm going to actually do in this case is actually use Helm to deploy this one. So I've created this C1 shell script here. So first I'm going to do Helm init, and we can do Helm status, and we can just kind of wait for that to happen, which won't be too long. Oh, it's already up. Okay, so then, now this one is interesting because I'm actually going to put some stuff in there that is specific to my deployment of Helm. So for example, let's talk about this external domain piece, because I think it's kind of interesting, and it's a problem that a lot of applications that are deployed into Kubernetes are going to have to solve. So in this case, they actually have an external domain that you can describe, that tells it what domain to expect the header information to come in at, right? And we're going to define harbor.c1.k8.work. Now you notice I didn't do that with Nginx, right? Because Nginx is just listening on all interfaces and it's saying bring it all, land it, it'll be fine. But in this case, maybe they have like particular media or other services that they want to be able to address by name, and they want to be able to handle that routing in such a way that it actually makes sense. So you have to give it a hint and say, when I address this service at all, it's going to come in at harbor.c1.k8.work, and from there you can figure out the routing. But if I wanted to add a subpath, right, if it was actually going to be like my c1.k8.work/harbor, this would be where you would put that instead of like the whole hosting thing. So interesting stuff there. So let's go ahead and do our Helm install. And this will throw everything that we've created into a different namespace, the registry namespace, and it should deploy everything. So let's do kubectl get pods -and registry. You see things are starting up. Takes a minute, lots of containers to download. Let's take a look at like what actually all we have here, right? So we have an admin server, we have Chart Museum, which is a way of actually hosting Helm charts. We have Claire, shout out to Quentin, who wrote Claire as an intern project at CoreOS. Quentin is an amazing person, by the way. We have a couple of databases that we're registering. We have a job service. We have Notary server, very exciting. We have Notary signer. We have our registry. It turns out that Harbour actually uses the Docker registry container for that, or a fork of it that they manage, the Photon registry. And then we have our UI. You can use self-signed certs. In fact, by default, I didn't provide any certs in my Helm in my Helm command, so it's all self-signed. I'm not doing anything with it. Now, back to something I brought up earlier, where we talked about like a fall through DNS. kubectl edit ingress -n registry. This is the ingress that is created by the Helm chart for Harbour. But I want to be able to trust the certificate that's in front of these two services, right? It's defining two hosts within its configuration, harbor.c1.kh.work and also notary harbor.c1.kh.work. Now, when I deploy the ingress controller, I actually, when I deployed the Ingress controller, I put up a default certificate. And what that means is that if I don't define a secret name within the TLS spec of an ingress, it's going to use that default certificate as the answer. If I want a more specific secret, I can define that here or create the secret ahead of time. So in my case, what I'm going to do is I'm going to delete this secret name here. And I'm going to right quit this. And what I've just done is I've told it so that I want to use the fall-through secret, the default secret that the Ingress controller has as the TLS certificate that will be in front of these two services. And I'm doing that because I want my browser to trust it, and I want Docker to trust it, and I want not to have to worry about self-signed certificates in front of my registry. I want to just be able to make everything work by hostname. So let's take a look at whether that worked or not. Oh, keep going to the wrong screen here. So harbor.c1, okay, it's not work. Well, it did work. I do have a trusted certificate, but the service isn't quite up yet. I have noticed it takes a minute on my little local environment to get everything working. It's probably pretty close. Let's do watch curl. You know, while we're doing this, I'm going to pass on one of my favorite curl tricks. I just tweeted about this on Twitter. I am Maui Lion on Twitter, M-A-U-I. That's my Twitter handle. Feel free to follow me if you're curious about crazy tips about security or Kubernetes. Reach out to me. I'm always available, and I love to answer questions, mainly because it helps me think about things from a different perspective than I might have thought about it before. So seriously, if you have questions about stuff, please throw them my way. I'm also Maui Lion on the Kubernetes Slack, so yeah, reach out. But here's the thing I was going to show you. Really neat stuff. We all play with curl all the time, but did you know about the resolve command? So say I'm going to do blah.c1.kh.work. I'm going to forward to port 443, and I'm going to send that to 1803. Now, this is somewhat redundant because DNS is already pointed that way, but I'm going to show you this trick anyway because I think it's pretty neat. Now what the resolve command does is, like, say I'm in a production environment and I want to change the, and I have a different load balancer or VIP IP, right, that is serving a bunch of stuff. And I want to validate that VIP works. I either want to validate the certificates that are in front of that VIP, or I want to validate the vhost configuration that is behind that VIP. One way or the other, I want to be able to target and set the host name for my query specifically at a locally resolved IP or a specific resolved IP. So what this line is saying is, I want you, for the purpose of this call, to resolve blah.c1.kh.work to the IP address 172.18.03, and I want to use port 443 for that resolution. And I can actually adjust both of those last two fields to match whatever I want. So if I do that command, I can see that it actually forwards, as we expect, to my known load balancer. But what if I did 5? Oop, not so happy anymore, because I don't have a node at 0.5. So that's just proving that it works the way it works. Pretty neat stuff. Yeah, curl resolve, totally a lifesaver if you're trying to troubleshoot some crazy stuff like, is your problem DNS? It's always DNS. Is your problem actually something with, you can solve so many problems with this particular trick. You can determine if it's DNS. You can determine if your certs are correct. You can determine if the vhost routing is correct. It's just a really good trick to have in your toolbox. That's the kind of stuff I share on Twitter. I guess that would be kind of like my equivalent of the normal Go trick, but anyway. Curl https : let's see, Harbour .c1.kh.work. Are you alive yet? You are alive. Hey, presto. Oh, on the wrong window again. That's frustrating. Welcome to the wonder of Harbour. Now, I haven't changed any of the default settings. So it's got the default username and password, admin, capital H, Harbour, 12345. So let's go ahead and log in here. Thank you, Nick. All right. So here is our Harbour cluster, and it's pretty neat. What it has by default is a project called library, and there's nothing in it. So let's put something there, shall we? So, Docker PS, Docker images, grep C1. So I have a little container that basically holds the kubeadm container, the kubeadm command, and I've created it, and I've gone ahead and retagged it with Harbour c1.kh.work, library kubeadm, and then the version of the thing that I care about. If you want to walk through that real quick, if I do Docker RMI, let's go ahead and blow that one away. Docker images grep kubeadm. So here's the base container that I made. It's just like, it was a Docker build -t kubeadm v1.11.2. And I'm going to retag that because now it's in my local registry because I did Docker build. So now I'm going to actually retag that to something that I could push toward a target registry. Y'all are probably pretty familiar with this trick if you've been dealing with containers, but I just figured out it might take a moment to show how this works. So since I have my kubeadm v1.11.2 container here, what I would do is just provide a new tag for that would describe in the front part what my target repository will be. In this case, harbour.c1.kh.work, library, because that was the name of our project, and we'll call it kubeadm, and we'll leave the tag alone. Oh, 2. Now if I do Docker images, grep kubeadm, I can see I now have the image tagged this way. Now nothing's changed, it's just the same image, it's referring to the same manifest. Nothing's interesting about this yet. If I do Docker push, this is where the rubber meets the road. Now, what's neat about this, though, is because I'm actually using a Let's Encrypt cert in front of the Ingress controller, forwarding back down to that registry, I don't actually have to tell Docker about the self-signed cert at all, because it's a trusted cert. It's in my local trusted cache, which is awesome. And that means that it simplifies my whole interaction with Docker incredibly, because otherwise I have to deal with a bunch of really kind of specific semantics around like a self-signed certificate. I have to put it in secure registry, I have to deal with all that. Just by putting a Let's Encrypt cert in front of my Ingress controller, I've gotten rid of all of that pain. So, neat stuff. Again, shout out to Let's Encrypt. So I do my Docker push. I can see that Docker command was able to authenticate or was able to validate that endpoint using the certificate already. I'm able to push to that target cluster. Guess I probably should have done a Docker login there, but I think I still have it cached from when I was working through this before. If you think about this, this is me copying the file from one place on my file system to a different place on my file system. Anyway. So now if I go into library, Lo and behold, we have a Docker container. Here's our KubeADM, and we can see that it's not signed. But what's this signed thing about? We'll talk about it in a second, but that's the Notary piece. Neat stuff. But I do have this vulnerability scan stuff. This is actually about Claire, that open source project that Quentin put up. Shout out to Quentin. If I do a scan here, what it's doing is it's pulling all the vulnerability information from a number of different sources, and then it's actually going to look at the packages that are a part of the underlying image. So in my case, it's an Alpine Linux image, and so I can basically pull a digest of the entire, of all of the packages that have been installed in that image, and then evaluate them against the known vulnerabilities that Alpine publishes. And if there are vulnerabilities, it will let me know, which is awesome. And it's sometimes, depending on the integration, Claire will actually also provide you, there is auth, but I'm just using the local, like, default username and password. You could totally integrate with LDAP, which is pretty neat. So here is my vulnerability. I got no vulnerability. It was able to check 36 packages, and it saw no vulnerabilities in any of them. Pretty cool. But what would really be neat is if this container were signed. So shall we explore Notary? I think we should. So, to get Notary working, what we're going to need to do is we're going to need to basically pull a copy of the CA that issued the signing certificate that is being used by the Notary signer within the cluster. But this is Kubernetes, so we actually can get that. We can get a copy of that certificate. Let's take a look at that. CD Harbour, CDC1. So again, I'm using the NVARC stuff, but let's take a look at what's actually being set. You can see I'm setting Docker Content Trust and Docker Content Trust Server. If I take a look at my .nvarc, we can see what we're pointing them at. So I'm turning on Docker Content Trust because I want my Docker daemon to actually start leveraging Docker Content Trust against that remote registry, or against any registry really. And I'm also pointing the Docker Content Trust server at Notary Harbour.c1.kh.work. Now I'm only turning this on so that I can sign the image and push it signed to the target server. I don't necessarily want DCT turned on for my entire Docker daemon, although that is something we could talk about. It's interesting stuff. So I've got these two things turned on, and these are flags that I'm going to use with the Docker Trust command. Check this command out. It's pretty neat. It's got a lot of what you kind of need to understand how to sign and revoke and push things up, create keys, and all that stuff. So moving into how this works. Notary is a service, a gRPC service that is held behind all of my Ingress stuff. So I can establish a secure communication to notary-harbor.c1.kh.work, leveraging that Let's Encrypt cert. But I also need to be able to provide a copy of the CA certificate to my local Docker Docker command, so that it knows that when the certificate is being presented by the signer is actually a trusted certificate. Otherwise, it would be like, I don't know how to do this. Yeah, it can be public or private. Docker, and it also has a token thing, right? So Harbour, you can actually issue tokens and use that token to authenticate to Harbour rather than just a username and password if you want to. So like Harbour is actually pretty complete. I was really more focused on like the idea of a registry and the idea of Notary, so that's why we're kind of going through this piece. All right, kubectl get config map -n registry or Notary. So YAML. So this is the CA cert for the signer. So I'm going to grab that CA cert. Now, why this is in a config map? I think I was going to open an issue on this. I haven't done this yet, but this at the very least should probably be in a secret rather than in a config map. Not a big deal, but probably should be. I mean, I'm not going to say not a big deal. It should be a secret because certs are secrets. Keep it secret, keep it safe. But that's how they got it. That's how they got it across the finish line with the Helm chart. So, and that's okay. Now for a little JSON path magic. Now that I know the dot data, I know the field name, I can grab the certificate that way. Now what this is doing is I'm doing the same get config map that I did before. I'm looking for the element Notary Signer CA cert under the element data, the JSON path stuff. So if I go back again to the top here, I can see that my first element in this array is data, and the second one I care about is actually Notary Signer CA cert. The challenge is that there's a period in the name, in JSON, well, so what I have to do is effectively double escape the period to make the query work. So, another little pro tip. There you go. Now, I said I had to grab that certificate. I also have to actually define that certificate within the CA associated with this Notary Harbour instance. So what I'm doing here is I'm actually going to grab that certificate output, and I'm going to overwrite the CA cert that I put in here earlier when I was practicing, and I'm going to place that, I want to do that here. And what this does is it enables for my user, for Docker to trust certificates signed by that CA. This is important for the Docker content trust piece. It's not important if you just want to use it as a registry, but if you want to get tangled up in the whole notary thing, this is kind of important. Okay. So now I have a copy of the CA cert. Now I have Docker content trust turned on. Let's sign that image that we presented before. Docker sign trust sign. And it starts asking me a bunch of questions, right? It wants me to enter a passphrase. Oh, you know what this is? I forgot about this. I didn't clean up my environment before doing this test. So rm, that's rf. What's happening here is that I had actually previously run this test, and so a lot of the trust stuff is still relevant on my local machine, but my target remote server, my notary that's actually up in Harbour right now, doesn't know anything about this world. So it's expecting that the local Docker daemon is expecting that the certs I have locally, all the trust stuff that I have locally, are still right, but Notary has totally amnesiac, right? I've blown it away and recreated it using ephemeral directories, and so it doesn't have any idea of the certs that I actually have locally. But that's pretty easy to fix, because all I have to do is that. And now I have no local trust data. And then I start getting asked for this other thing, which is like a new root key, new domain key, all that other stuff. And this is where I'm establishing the local trust that I will use to sign and extend trust to images. Woo! All right. So after entering my my secrets and stuff a bunch of times, now basically what I've done is I've created a new root key, I created a new repository key, I created a new admin key because I am user admin on the registry. I've created a new signer called admin. That signer is actually hosted in the signer. I've signed the image. I've pushed up an image and a manifest associated with that image. And again, it asked me again for that admin key because I needed to actually authenticate that to be able to push the change up to Harbour. Let's go look at Harbour. If I do a refresh here, what? So now I have a signed image in this repository. So that was kind of a quick overview of what you can do with Notary and how it works. Some of the other interesting stuff, oh, that was the other thing I wanted to share with you. If you're interested in Notary and you want to play with like what that is and how it works and all that stuff, there's a reference link to a bunch of really interesting stuff down here below. And this is where I'm going to kind of get into like why that's interesting. So securing your Kubernetes delivery pipelines with Notary and Tough. You've seen Google's like binary authorization stuff recently. There was an announcement that Google now has like binary authorization so that you can establish trust in your build pipeline and extend that trust down to the execution layer and make sure that the binary or container that you're running in your production environment is actually, that you have image provenance, that you know that image came from a continuous deployment process that you trust all the way back up to that signing process. These guys kind of get into how to do that with free stuff, right? With just Notary and Tough, which is really, really cool. And Google's project GraphES is another one of those ones that actually addresses exactly that need. How do we do this trust stuff in our CI pipelines and stuff? So go watch this video. Great video. They cover it pretty well. And it basically takes the story that we've told so far about how do you get from Harbour, how do you use Notary? Well, now that I have signed images, how do I actually make use of those within a Kubernetes cluster? These two guys, Liam and Michael, both work for IBM, and they have actually written an open source project called Porteus that would allow for that. But they get into what Porteus is and how it works and all that stuff in the video. Go check it out. It's really, really cool. Shout out also to Notary GitHub and Tough GitHub, 2 more projects in the CNCF. Really awesome projects for like being able to manage all of this stuff. And another link to a tweet that I found when doing a little research, which I thought was pretty cool. Chris points out that NYU is looking for a research associate to work on Tough. So if this really floats your boat, if you're really into the security aspects of all of this and you actually want to spend some time doing some research on it, go try it out. You know, it's cool stuff. All right. Let's do the last thing I wanted to. I think I've covered everything that I wanted to cover today. Are there any other questions? How can I revoke the client in this case? Well, hold on, let me look at the questions here. So, how can I revoke the client in this case? I mean, if the client should no longer sign the Docker images, is it also possible to know which image is signed by who? So, there are 2 commands in play here. So Docker trust gives you a couple of different interesting things. You can do things like inspect a particular image, whether it's locally hosted or not. You can inspect a particular image for those things that have signed it. You can revoke trust for an image, and you can also sign a new image. So if I wanted to say I no longer want to trust version v1.11, I can revoke that trust using the Docker command. The other command that's in play is Notary. So Notary gives you a whole bunch of other capability specifically around like managing the delegation and all of the other stuff that's within the Notary server itself. Now, I didn't dig a mile deep on that. Feel free to like really to get into that one yourself. And I may end up doing a follow-up episode as I dig further into Notary around like how to make the whole Porteus image provenance thing work within Kubernetes. It's definitely one of the ideas I have for a security episode of TGIK, because I definitely would like to see maybe a well-established pattern for how to trust those images that you have locally, right? And Notary provides a lot of capability there. Like you could effectively delegate trust to things like GCR and other places, so that you can actually have a local signer, a local notary on each cluster that says, I will sign every image that comes into this cluster or not. And then you could have something like Porteus, which would sit as an admission controller in front of your Kubernetes cluster and say, if it's not signed by Porteus, don't let it in, right? And in this way, you can kind of you can put yourself into a position where nothing can be deployed to your production cluster without first having some sense of provenance, right? Is it signed by something that you trust? And if it is, how did you establish that trust, right? Because you can make all that decision before you sign a thing, right? You can pull it down, you can evaluate it with Claire, you can do all of the stuff that you would like to do to establish trust with that particular image before you sign it. And then once you do sign it, then you're kind of opening the door that somebody could deploy it into your Kubernetes cluster. But definitely check out like the Porteous project, which gets into this a little bit. I think that I may do like a V2 of this episode and bring up like an example cluster leveraging this, right? So we have a Harbour already. We have Notary already. Let's talk about how we could actually put Porteous in front of a Kubernetes cluster and use it to establish trust with image provenance back toward Harbour and Notary. So if that would be interesting to you, let me know in the comments. I think that's what I got right now. And yeah, so hey, thank you so much for logging into TGIK and giving me such a warm welcome for my first episode of TGIK. It's been a real pleasure, and I could definitely see myself doing this a few more times. I have a lot more to talk about, and I hope you guys have a lot more to listen to. So thanks again, and it's been really fun. So y'all have a great weekend.